Having learned the equations of motion, let's apply these equations of motion to solve few problems. So question number 1. A car moving at 108 km per hour along a straight road begins applying brakes so that it uniformly retards to a speed of 36 km per hour. What is the acceleration of the car if it moved by 500 meters during the application of brakes? So there are few things that I have highlighted. The first is that we have to check before attempting any question. The first tip is that we have to make sure the units. Here all the units are given in kilometer per hour. The speed units are given in kilometer per hour and the distance is given in meters. So when it is so, our first task should be to make sure that all the quantities are expressed in a unique unit. So let it be SI unit. So kilometer per hour has to be converted to meter per second. So that should be the first step for solving this problem. Then it is given that along a straight road, so whenever it is mentioned straight, it means that it is going with a unique direction or the direction is not changing. The speed becomes simply velocity. Applying brakes so that it uniformly retards. So whenever you have this word retards, it means negative acceleration. So the acceleration must be given the negative side. To a speed of 36 km per hour, what is the acceleration of the car? They have asked you what is the acceleration of the car if it moved by 500 meters. Distance is given. So now let's write all the data that is given to us. So we have first the initial velocity is 108 km per hour. Since it is in kilometer per hour, we have to convert it into SI unit, that is meter per second. We multiply it by 5 by 18. So we can do the cancelling, 18 and we will be getting 6. So that reduces to 30 meter per second. And then similarly for V, 36 km per hour, we convert it into meter per second. So 36 into 5 by 18, we multiply by 5 by 18 so that kilometer per hour becomes meter per second. This is a quick tip. So it becomes 2. So we finally get 10 meter per second. So now we have converted it into SI units. And one more data that is given to us is the distance that it has moved is 500 meters. So we have been given the two initial velocity, final velocity and the displacement. So using this, we are supposed to find the acceleration. So we can employ, there is no mention of any time in this formula, in this problem. So we can go with the third equation of motion. 2a is equals v square minus u square. Here a is the acceleration. So once you rearrange the terms, so 2s can be taken to this side, so it becomes v square minus u square by 2s. The RHS becomes this form, and straight away evaluate acceleration. All the information is given to us. We can substitute the values. So 10 square minus 30 square equal divided by 2 into 500. So this is how the form 10 square minus. So one quick tip for solving this kind of problems is we can use the identity a square minus b square equals a plus b into a minus b. So this term can be split into 10 minus 30 into 10 plus 30 without even so this can once you evaluate it directly, there can be cause of errors. So this can if you use this technique, you can straight away evaluate it, and once you solve it further, we get a negative sign. 10 minus 30 is a negative sign, and finally we get minus 0.8 meter per second square. So this negative sign indicates that it is uniformly retarding, negative acceleration. Remember, whenever there is a negative acceleration, there is always something that is trying to stop the motion. Here we are applying brakes, and the brakes acts against the direction of motion. It tries to stop. That's exactly a remark of this problem. Let's go to the next problem. So in this problem, a ball initially moving with a velocity of 5 meter per second was pushed by another ball so that it began moving with a uniform acceleration of 4 meter per second square. How long should the ball be pushed so that it moves by 3 meters? So in this question also, see, if you look all the units, first let's check all the units. Here all the units are given in SI. So you should not do any kind of conversion. And also remember that all the formulas that we learn in this chapter is applicable only when the acceleration is constant. So here they have mentioned uniform acceleration. Now they have asked you how long should the ball be pushed, meaning how much time. So you are supposed to find time. So whenever you are supposed to find time, so the two equations should come into your mind. That is the first equation and the second equation. Since they have also specified the displacement 3 meter, it hints that the correct equation of motion that we have to use is the second equation of motion. Let's see how to go. So first let's write all the data that is given to us. Initial velocity is 5 meter per second. acceleration is 4 meter per second square, the displacement is 3 meters, and you are supposed to find t. So we directly use the equation of motion, second equation of motion, s equals ut plus half at square, where s is the displacement, u is the initial velocity, and a is the acceleration, and t is the time. So you can directly substitute these values. So once you substitute these values, you will be getting an expression which has t and t square, a quadratic equation in t. And this can be rearranged into this form. And now we have to solve for t. So there are two methods. So the brute force method is by using the quadratic solution, that b square determinate form. But so there is a smarter way to do it. Let's see that this phi t, can be split, written as 6t minus t. So once you write this, you can rearrange the terms. You can take something as common in this. So we can take the first two terms. You can take 2t as common. We get t plus 3. The second time we can take negative 1 as common. We will get t plus 3. So t plus 3 and t plus 3 are common. So we can be rearranged this into 2t minus 1 into t plus 3 equal to 0. So this condition has to be satisfied if either of this is 0. So the first condition, if this quantity is equal to 0, so we get t equals half seconds. And if this condition is 0, it satisfies t equals minus 3 seconds. So there are two conditions. But we know that the time is a positive quantity. Time always increases, and there is no meaning to negative time. So this mathematical solution can be avoided, and we go with t equal to half second. That is the solution for our problem. So the next question, this is from uniform circular motion. If the speed of a body moving uniformly along a circular path of radius 2 meter is 20 meter per second, how much time it takes to complete one rotation? So in this problem, they have asked you time. And let's check all the information that is given to us. 2 meter, 2 meter per second, 20 meter per second. Yes, they are in SI units. So we can straight away write this, what all things are given to us. So we have V equals 20 meter per second and R equals 2 meter. Now we can directly go for the uniform speed formula for the circular motion. V equals 2 pi r by t, where t is the time taken for one complete rotation. They have exactly asked you that. So we can rearrange the terms, and you can have t equals 2 pi r by v, and we can straight away substitute the values. R becomes 2 meters and v is 20 meter per second. We can straight away substitute. So we get pi by 5 seconds, and pi by 5 is approximately 0.63 seconds. So this is how we finish uniform circular motion problems.